All right, I'm going to help you with the next set of problems that you have there, which is 7.4a. It's 10 problems here. I guess in the middle. It says, number one, Nancy drove her cart across the yard at a constant rate of speed. And then it says, based on the equation, D equals RT, where D represents the distance traveled, R represents the rate of speed, and T represents the number of hours. It says here, which of the following equations represents the distance Nancy traveled on her golf cart if she drove at a constant speed of 12 miles per hour? And so it says there, A is 12 is equal to rate times time. B, distance is equal to 12 times rate. C equals 12 times the distance is equal to 12 times the time. D equals 12 times the time. So just think here, if you're going 12 miles per hour, so let's say you're going 12 miles per hour, so that means in 1 hour, this is going to equal 12. Well, 2 hours will equal, well, double that, 24, and 3 hours, 12 times 3, which is 36. So think of which of these would that work, where distance, because distance equals rate times time, your distance would be this, 36. Well, so in which one of these four will this work, where you can put 36 is equal to the rate? What's the rate? The rate is 12 miles per hour, okay? 12 times the time. Well, how long did it take to get to 36 miles? It took 3 hours. So 12 times 3 was 36. So think which of these would this make sense? Think of the 2 hours 24. Okay, so distance equals rate times time. Well, the distance is 24. So 24 equals the rate, which is 12 an hour. 12 times what? Well, how many hours does it take you to get 24? Well, 12 times 2. So think here, which of these would fit this one of these answer choices? Okay, let's go to number 2. Okay. So it says there the Texas Roadrunner can run 6 6/10 miles in 20 minutes. Represent the Roadrunner's constant rate of change in miles per hour. Record your answer and fill in the bubbles. Be sure to use the correct place value. And so think here, in 20 minutes, well, I'm going to put here 20 minutes. He can do 6 6/10. Let's do that at decimal. Well, that's 6.6 in 20 minutes. Well, how many, think of here, how many minutes in an hour? Because it wants it in miles per hour, you see. And so I know in an hour, 1 hour is equal to 60 minutes. So then I think that, okay, well, if he can do 20 minutes, every 20 minutes he can do 6.6 miles. Well, how long will it take him to get to an hour? Well, if you look at the clock here, if you look at 20 minutes, it would be, this is 5, 10, 15, 20. So that's 20 minutes there. And in those 20 minutes, he's going to go 6.6 miles. Well, from here, let's put another part here. From here to here, 5, 10, 15, that's another 20 minutes. And if I keep going, I'm going to highlight here, I'm going to highlight, so I'll use this. And then from here to here, that's another 20 minutes. So think there, okay, 6.6 here, 6.6, another 6.6 here, because this is 20 minutes, 20 minutes, 20 minutes. So then in 1 hour, how long, or what's the total distance he would have traveled? Okay, number 3. A rancher feeds his cattle the same amount of food each day. The graph below represents the relationship. Based on the graph, which answer choice defines the constant rate in this situation? A, 1.5 bags per day. B, 3 bags per day. C, 2/3 bags per day. Or 1 bag per day. So what you want to do on this kind of problem, okay, so you want to know for 1 day. Okay, so just 1 day. Okay, what does 1 day equal? Well, if I look at the horizontal line, which is a horizontal line, where the horizontal line is. Look at that one. That's telling you the days. Okay. For example, in 8 days. Well, let me pick one in the corner, like this one. Right here. Okay. For example, that one. Okay, right here. This one here, right there. Okay. How many days is that? Well, if I look here, it starts at 0. This would be 1 day, 2 days, 3, 4, 5, 6, 7, 8. So in 9 days, okay, in 9 days, how many bags of feed will he have used, the rancher? Well, if I look at 9, that's actually 6. So then he would have used 6 bags. So in 9 days, I'll make this as the days, he'll use 6 bags. Okay, that's 9 days. Well, you want to know in how many bags will he use in 1 day? So think there. If you know 9 days, he'll use 6 bags. Well, how many will he use in 1 day? And let's pick another one here. Look, in 6 days. In 6 days, which is right here, how many bags will he use? Well, I look there, that's 6. In 6 days, he's going to use 4 bags. So in 6 days, he'll use 4 bags. Okay, so try to figure out, okay, how many bags will he use in 1 day? Because they want to know the constant per day. Number 4, a restaurant uses cartons of eggs every morning. The number of cartons used are shown below. It's 30 minutes. As you can see, this egg here doesn't, it's the one that goes in here. So there's only actually 6 here. 60 minutes. We have these 5 in here and this one here at 6. And then these 5 and then this 6 one here. There's not an extra one. Okay, that's the one that goes in here. And 90 minutes, we have the same thing. This egg is the one that belongs here in this space. And so we have 6, 6, 6, that's 18 in 90 minutes. Based on the display, which of the following best describes the rate of eggs used? And so look at the choices. F, the restaurant uses 12 eggs per hour. G, the restaurant uses 6 eggs per hour. H, the restaurant uses 1 egg per hour. Or J, the restaurant uses 18 eggs per hour. And so you got to think there, well, if they want it per hour, then I'm going to just okay. So let's think there. Okay, this one's 6 eggs here. This was what, 12 eggs, and this one's 18 eggs. So just look at the picture here. Remember, this is in minutes. Well, how many eggs would be in 1 hour? Number 5. Tommy has 3 dogs. Last month, he bought 5 pounds of dog food for $7.95, 8 pounds of dog food for $12.72, and 15 pounds of dog food for $23.85. What is the constant cost of the dog food per pound? All you have to do is find the cost of 1 pound. Per pound means 1 pound. So how much does 1 pound cost? Well, we know that 5 pounds, $7.95, it's going to cost you 5 pounds. Well then, how much would 1 pound cost? Okay, that's the question. How much would 1 pound cost? The other one is 8 pounds, so $12.72. 8 pounds. Again, how much would 1 pound cost? All you have to do is TiVo, and you get the answer. Number 6. Tickets are on sale for a 1-year pass to an adventure park. Each ticket sells for $65.50, which equation can be used to determine T, the total cost of N, the number of tickets purchased. F, N equals 65.550 T times T. G, T equals N plus 65.50. H, T equals 65.50 times N. Or J, T equals 64.50 times N plus 1. So think there, if the tickets, each ticket costs $65.50, so one ticket equals $65.50. And so then you gotta think that, okay, how much would 2 tickets cost? Okay, so then just think there, if one ticket costs this, well, how much would 2 tickets cost? Okay, well, obviously it would be, one ticket is this, 2 tickets would be 65.5 times 2. And that'll give you the price for 2 tickets. Well, which of these equations would that work? Well, you would get the answer. And that's what you got to think about. Okay, number 7 there. A copy machine can make 250 copies in 4 minutes. Represent the constant rate of change in copies per minute. 125 copies per minute, 62.5 copies per minute, 50.5 copies per minute, or 4.2 copies per minute. Plain and simple, in 4 minutes, I'll put here, in 4 minutes, you can do 250 copies. How much can you do in 1 minute? And answer the question. Okay, number 8, which of the following table shows a constant rate of change equal to negative 1/4? So in this problem, you're going to have to use the change in the y over the change in the x. You're going to have to find the pattern. So think here. You have to find the pattern from here to here. For example, let's look at G. I don't know, maybe it could be the answer. G. It's going from 0 to 2 and 2 to 4. So obviously, the x part, the change in the x is going from here to 2. So the x is 2. And then the change in the y's, well, let's look at the y's. It went from 0 to negative 1/2. So if I look at my number line, if I go from 0 to negative 1/2, well, if this is 1, that means that 1/2 is somewhere right here. That's negative 1/2. And so that means that if that's negative 1/2, that means it's going to the left. And so that means if you go to the left, if you go this way, then it's a negative. So that means it's a negative 1/2. So this would be a negative 1/2. And then from 1/2 to 1/4, well, again, this is 50. Let's say this is 0.50. This is 0.25. Well, you're moving another, you're moving what, 0.25 here, because 0.50 and 0.25, you move a negative 1/4. And as you can see, it's not the same thing. This pattern doesn't work. So that means that this wouldn't be the answer, because you're not moving them on the same. Like here, this was 2. From 0 to 2 was 2. 2 to 4 was 2. So that the pattern has to be the same. It has to be, the pattern has to be in the x's and the pattern has to be in the y's. And here, there was no pattern, because it went from 0 to negative 1/2. It went down negative 1/2. But then here, it didn't go down to negative 1. It went down to negative 1/4. So then the pattern doesn't go along. It doesn't make sense. So then this is not the answer. You have to look for the one that is the pattern, the one that follows the pattern. This one here, all you gotta do is read. I'll read it, but I won't do too much. Harold has taken out a loan for $500 that he will repay over 20 months. The graph here. Obviously, when you pay up a loan, you're decreasing every single time you keep going, because you pay less. What is the constant rate of change in the loan amount per month? A, the loan amount decreases 25 per month. The loan amount decreases $12.50 per month. Or the loan amount decreases $2.50 per month. Or the loan amount increases D, 25 per month. Think here, remember, when you're paying off a debt, the loan has to keep going down, because you're paying it off. That means you owe less. So think here in time. Think there per month. Per month means 1 month. So think there were, how much do you pay in every single month? Well, here's 4 months. You're gonna be here. So this is 4 months. Okay. So think there. Okay, how much is 1 month? Look, this would be 2 months. Okay. And think what you would be in 2 months. Well, you would be here. Okay. So think there. How much would you pay per month? That means every single month. And the last one here, the table shows the relationship between the time and distance and the red kangaroo can travel. Based on the table entries, what is the kangaroo's rate of speed measured in miles per hour? Just think there, in 15 minutes, that means from here to here to here, 15, he can do 11 miles. This is like problem number 1. And just figure it out, and good luck.